Sorry. Just now we're taping the other video all the way in slow mode, so it burned up all the memories. Anyway. All right. We're looking at this. Now we open this up. This is just the dumb thing to do. So R4 minus 2R4 2Z2 plus Z4. That's why I want you to do it, because just DZ. This is occurs from minus R to R, right? Okay, we're gonna just look at this. So, do we write another?
Sure.
Another time, okay. Equals to half rho pi. Okay, now minus R to R. R4 dz. Actually, R4 just go out, but we're just minus 2R square z square dz plus z4 dz, right?
Yeah.
This is all from minus R to R. Minus R to R. Okay? Okay, now half rho pi. What's this one?
R to the power of 5 divided by...
Wait.
Hold up. It's... 0.
How do you get it to 0?
Because, like, R to the power of 5 divided by 5, and then you do... If you put in R and negative R, then it'll be R to the power of 5 divided by 5 minus R to the power of 5 divided by 5.
What? Say that again.
Because, like...
I didn't even understand it.
Okay, so the interval of it is like R to the power of 5 divided by 5, right? If you
No, it's a Z. R is the diameter of this thing. It's a constant. Remember,
Sure.
This is R square minus Y square. This R is a constant.
Oh, okay, then it's just...
In other words, this R4, I should do this. You can take it outside.
Oh, then it's just R and minus R.
Which is what?
0.
What? R minus R is 0.
2R.
What's this?
Huh? What's what?
What's this one?
Oh, that's Z cubed divided by Z. Divided by 3.
Divided by 3. What divided by 3?
R cubed. 2R cubed divided by 3.
Right. What's this one?
It's 2Z to the power of 8. No, 2Z to the power of 4 divided. No, 2Z to the power of 5 divided by 5. Yeah.
2 what?
2R. Okay, yeah, I'm getting retarded by the second.
Right?
Yeah.
Okay, now. This is obviously, this is 2R, and there's R to the 4. This is R to the 5. Okay, I forgot that one. So R to the 5 will go out, right? So this is the half rho pi R power 5. Why did I write 5 that way? Okay, now. This is the 2. This is the 3. This is the 2, right?
Yeah.
So we're talking about, what's the denominator?
Oh, like
Now we can do
30.
What?
The common denominator of 3 and 5 is what?
15. I thought you meant 2, 3, and 5. I was like, what?
15. 2 is what?
What? Oh, 30.
Minus 4 is what?
That's 20.
20. Good. What's 2?
6.
6. Okay, good. And this is what? This is what?
That's 16.
16. Right?
Yeah.
So this comes to okay, you can change that to m yourself. I'm not going to do it anymore. Okay. Get that to m yourself, okay? Same thing. Anyway, okay. We're done. This is the end of mechanics. Before we leave, we really leave, right? I want to give you an idea of how the problem set will come. Okay, we'll just take one example of wedges. Okay. So normally you get this. This we have done. Let's say this is the wedge, right?
Yeah.
And this thing, the wedge is fixed, not moving, right? So you have this mg, right? This goes along this and then perpendicular to this, right? This
Yeah.
mg is split into this and this. This is theta, and this is, when you look at this, similar triangles, yeah? This is your regular geometry stuff, right?
Yeah.
So this is mg, what?
Huh? Which one? Which side?
This side.
Oh, that's mg sine.
Sine theta, and this is mg cosine theta, right? This is mg cosine theta, right?
Draw
So
sine is. Right.
yeah. I on purpose did not draw it, just so make it a little challenging for you. Anyway, this thing moves. Let's call this x, right? If this is the x direction, it moves in this way. Is mx, right? The acceleration equals to mg sine theta, right? So if they give you anything, this is we're not gonna take. Oh, this is going to find that page. Yeah, good. This is the page, right? When you know A, you know everything.
Yeah.
If they tell you the velocity, and then you know the A now. A equals to the, okay. A equals to g sine theta, right? Once you know the A, you know everything. They give you something already. This is come back down to the same thing, right? You know the entire motion, but you know this is a differential equation. You need to know something. They have to tell you at the beginning this thing is not moving, and at the point 0 not moving, and now you're in business. Or this thing is a point 0 moving as 1 meter per second or something. Then you're in business. Otherwise, you don't know. Right, because this is two degree, the second degree derivative equation. You need two constants. Every time you take an integral, there's one constant. You take an integral again, there's another constant. You don't know, right?
Yeah.
So they need to give you at this place, for instance, the position and the speed for this thing, where it is, and what's the speed at a given time.
Okay.
That'll be okay. Or give you something else, you know. Or say T1 at a certain place, T2 at another place. That's good enough too. They can play this somehow, but it's all just that. It's not a big deal. Actually, make this as a problem. At the time T1, this thing is at x1, and at time T2 is x2. Solve for the motion. You know, this x equals to x at any time at t, okay? At time t1 is at x1, t2 is at x2. Actually, this is a pretty nice problem for you to solve. Solve that one, yeah? It's homework.
Okay.
Okay. All right. Let me just help you out a little bit, okay? When you look at this, right, you take an integral of this, it becomes x1 dot, right?
Mm-hmm.
This equals the g sine theta t, right?
Mm-hmm.
Plus v0. This is some kind of a velocity. This is one constant, right?
Yeah.
You take another integral of x equals to half g sine theta t squared. You're doing it against t, right? Plus v0t plus x0, right?
Yeah.
Okay. Now for this, you know, t1 times t1 is x1, and then t2 and x2.
Uh-huh.
It's easy, right? This is the equation.
Yeah.
You don't know x0, y0. I mean v0, x0. But you know you put these things too. You have two equations. You solve for two variables, two unknowns. Yeah, this is doable. All right. The here is how they. Not just whatever. Okay. Here, I want to do this part just to tell you how they will give you problems, how they sort of screw your mind, so to speak. Now this wedge moves. To make this a little more interesting, right? Here's your ground, right?
Yeah.
Now they put the wedge on it, right? This wedge has a mass which is m, right?
Mm-hmm.
That's the same. You put a thing on it, right? And this thing, of course, they have mg, and then there's force going down, and this going perpendicular to it. Okay. Now they tell you here. Okay.
Yeah.
They're gonna put a force on it. See, they ask you how this little thing gonna move.
Depends on how big the force is.
Oh yeah, they just want they just want an equation for it. They just want a function for it. And the function contains f0, and then just whatever f0, so be it, kind of thing. Okay.
Yeah.
First of all, f0 drives m and m, right? F0 drives both of them, right?
Yeah.
So you can say, right, F equal to 0, ma.
Uh-huh.
So however it's going on, business going on in there, you can treat these two things as this one thing. And this one thing moves at this acceleration.
Yeah.
Yeah? Now, when this is moving at a certain acceleration, then you need to write your equation for to solve this thing, because you put an f in there, this thing moves, right?
Yeah.
And when it accelerates, there is a force between the two, because this is getting onto this. Yeah.
Mm-hmm.
When you push this, some of this force exerting on this.
Yeah.
Right. Okay. You need to deal with that. Okay. And then there's another way of doing this. It is they're going to just say this. Okay. You have a wedge, and you put it in there. An object, right? Now all they're going to say is at the time 0, right? This thing, nothing moves.
Yeah.
And now they let go.
Okay.
Of course, this thing gonna glide down, right? Once this glide down, this wedge is gonna move that way.
And isn't it just gonna go down more?
Oh, they don't care about more or less. They just want a function out of it. because this thing has a force like this, right? Right.
Yeah.
And this force has a component that's gonna that in that direction. This force has a component of this and this, right? This gets added up into this,
Yeah.
right? These two forces on this block. This force, the ground gonna support, gonna cancel out this one. This force is gonna push this wedge over that way.
Yeah.
Yeah. And they want you to write an equation and solve this one.
Okay.
It's actually relatively simple, the stuff. But okay. Should I okay. I give you the trick of doing it, right? Assuming in either case, forget about this. In either case, you write the equations, okay? Assuming this, don't worry about this, okay? Assuming this is n. Unknown.
Yeah.
This force is unknown. The force between the two blocks. And then for this block, right? You know the F, you know the N, you can write equations.
Yeah.
And then you know on this block, you know the F, you know this N becomes an unknown force. Mg you know. N you don't. N is actually, this is okay. This is a bad way to write it, obviously. N is like this N is on this. Actually on the other one is like that. Right?
Yeah.
This is that board pushing this. It's not in this direction. It's in that direction. Okay? Ignore this anyway. Right? You assume this N to be another variable.
Yeah.
And then you solve for it.
Okay.
Okay? This is the same thing. Assume you have an N, right? Well, actually, don't look at this. Look at this first. You assume the N, right? You don't know the acceleration of this. You don't know the acceleration of this. Yeah?
Yeah.
But you know, overall, this thing is not moving. As a unit, this thing is not moving. That's one equation, right?
Yeah.
And then this moves and this moves. Yeah? The overall not moving, so to speak, you can solve for N.
Yeah.
That condition. You have a condition, you're going to take out one variable. You understand that concept, right? Did you get that concept? When you know something, when you know one thing, you can take out a variable.
Yeah.
When you know this whole system not moving, you can take out the N when you actually write it off. Of course, the sum of the force on this block contribute to this acceleration. The sum of the force on this contribute to that acceleration. That contribute. You have three variables. This acceleration, and this force between the two. You take out this force between the two by knowing that altogether this thing not moving. In other words, this acceleration, and this acceleration is not totally independent.
Yeah.
These two acceleration comes together. They're not moving. This whole thing not moving. Yeah. You can do it any way you want. There are many ways to do this, but this is two problems.
Yeah.
That they screw you with, and you can look at the answer, but I actually solved this. Just make sure this thing works, but you should do it by yourself. Okay. Normally they throw you out because at this time, right? You pretty much they assume you know the algebra, right? When they assume that you know algebra, they're gonna give you a condition, and then give you a variable. The trick here is really you don't know which variable you're gonna assume. It's the force between these two blocks. You make that an unknown, an x, so to speak.
Yeah.
then you use the fact that this whole thing now moving. Actually, this is I'll give it to you anyway, right? This whole thing is moving at this acceleration. You use that condition to take the n out after you write up all the equations. But then there's also a little bit of something else. That's how these things these relative motions.
Okay.
You know, you assume this is acceleration. Let's say acceleration m. You say this is acceleration small m. You gotta write this carefully so don't mix up these two. Or you say this is a big, this is small, right? Yeah?
Yeah.
And then you want to solve for it.
Okay.
Yeah, take some thinking. The nice thing about this, all of these type of problems, it takes a little bit of thinking. Even after you know, I tell you the trick of it.
Mm-hmm.
It still takes a little bit of thinking to get it done. But anyway, this is something for you to think about it. And since the high school electromagnetism is basically just informational, so they're gonna give you whatever information, you just take it, because the form, the mathematics of it really get into the three-dimensional differential equations.
Mm-hmm.
Because when there's a current, electrical current going through, right, there is it creates a magnetic field.
Yeah.
And when this is stable, this magnetic field is stable, so that's that. However, if you just put a current through, right, this magnetic field changes. This magnetic field will create an electrical field.
Yeah.
And that electrical field, since it's changing, they'll create a magnetic field. You understand that, right?
Mm-hmm.
And you know the radio waves, right? All comes that way. And this EM wave, electromagnetic wave, right?
Yeah.
It's going through, it's 3D. It's always 3D. You can't, there's no way you're going to do this in a 2D situation.
Mm-hmm.
Yeah, you have a magnet, right? You have a magnet, right? The magnetic field goes from north. This is North Pole, South Pole, magnet, right?
Yeah.
Like that, right? There's no way you're gonna do this in a sort of a 2D thing. So this the equation, the derivative equation, is a 3D situation, and they're not gonna give it to you. They're not gonna even give it to you, that equation, in high school or college. Actually, I don't know. Maybe college they have to do it. They do it. Then they have to really get the math ready.
Yeah.
For that, and I didn't get that math ready for you. I don't know if what I'm gonna check to see if they're gonna do any of this. If they do, we'll do it next year.
Okay.
But this year, this is just it. But do this. Okay.
Okay.
All right. And then there are in physics. There are a lot of other informational stuff in. I mean, I don't mean in physics. I mean in dynamics, in this mechanical stuff.
Mm-hmm.
The book to read at this point, because you have a lot more math than what's in there. The book to read is Feynman's lecture on physics, and if anybody has a problem of buying it. Actually, the last edition that they published out, they put it into shiny paper in a very small print and whatever. If you don't like it, Caltech has talked to the publisher, and they put this book online for free. I think it's feynman.caltech.edu or something. You can just search for it. It's very easy to find, and that's how you really get behind all this math. They talk about sound waves, talk about all kinds of things, and if you really want to know physics, read those books. But this is the foundation. What we're doing, this whole series, is to give people a mathematical foundation to understand high school physics. This is in no way an attempt to actually do high school physics in 3-4 days or something. How many days we've done it? A week. Let's just say a week, not even a week. This is in no way that all that information going to put into this. But however, information is easy. It's the logic behind the information that's hard, and I think we've done, at least we intend to do all the logics behind all that information.
Yeah.
So that's that. Have a good summer.